In the last video, we have seen what a circuit breaker is and how a circuit breaker helps in fault tolerance in a microservices architecture. So we have, you might have encountered various terms like circuit breaker, fault tolerance, a fault tolerant design. So all of these sums up to design a system in such a way that in an event of a failure, the system should be capable enough to at least operate at a minimum or a reduced capability, if not with a full potential. So a fault-tolerant design enables a system to continue its intended operations, possibly at a reduced level, rather than failing completely. The circuit breaker majorly has three states: closed, open, and half open. Closed means the circuit breaker is closed, all the services are working fine, the communication between service A and service B is working properly. The open state means the link between the service A and service B is broken, maybe because service B is not available, or some of the component or some of the failure is happening in the service B side, right? And service B is unable to serve the request. Then the circuit breaker goes into an open state. Half open state, as the name suggests, it is half open, half closed, which means it will block certain requests and it will allow certain requests to service B, and the request which it allows to the service B will determine whether the state of the circuit breaker will go to back to the open state or to the closed state. So if we look into this diagram, what we can see is, first, the circuit breaker will be in closed status, which means the services are working fine. Service A is able to communicate with service B. Then suppose service B is down or having some issues, then the API request to service B from service A will start failing. And if the failure of those API requests reaches a certain threshold which is configured in the circuit breaker configuration, let's suppose 50% of the API request is configured as a failure threshold. So if 50% of the API request is failing, then the circuit breaker turns the circuit breaker status into an open state, which means blocking all the API requests from service A to service B. Now, we also define certain time period in the configuration for a circuit breaker to wait in an open state itself, so that those time period will be used by the service B to recover and be available again. So after the certain wait duration, the circuit breaker will go from open state to the half open state, which means it will be blocking some of the requests and it will be allowing some of the requests. So the number of requests which will be allowed is also configured in the configuration. Suppose 5 or 10 requests are allowed during this half open state, then all those 10 requests will be allowed to the service B. And if those 10 requests are still failing, all of them are still failing, or the failure rate is still matching the threshold, then again this half open state will go into the open state, which means it will again block all the API request for the next configured wait duration, so that the service B will try to come up again. This time, suppose all the requests which are being allowed in the half open state is actually passing or is actually returning a successful response. It indicates the circuit breaker that service B probably has come up, because the calls which were permitted to the service B in a half open state, all of them are successfully passing or successfully returning the response. Then in that event, the circuit breaker will turn the status to the closed status, which means that the failure rate were below the threshold, so it can be safely assumed that the service B is working fine and is able to serve the request. Now let us see how we can actually configure the Resilience4J in our Spring Boot application. So this is the application.yaml file which we'll look into later. First of all, what do we need? The first thing which we need is, let me open my build.gradle. The first thing which we need is, we need the Resilience4J Spring Boot core module from the Resilience4J library, right? And the version, you can also specify the latest version, but I have chosen 1.7.0. Then the other two dependencies is actually dependencies to help our Spring applications to also monitor the health metrics of the APIs, which will essentially help Resilience4J to determine whether how many requests were failed, how many requests were passed, what is the threshold, and how the system is behaving. And from the project side, I have just simply created one simple project in a Spring Boot application which I have named Circuit Breaker, and there is a controller, order controller. It has two API. One is a failure, so this will replicate basically a failure API request, and the other API is a slow API request, which will actually induce a slowness in an API. there is a fallback method as well, because in an event of a failure, circuit breaker will fall back to this particular default method and it will return this particular response back. Now I have annotated the API's method with add circuit breaker annotation, and the name which I have given here is service A, and in this service B. So service A and service B is basically the circuit breaker instances which we will configure in the application.yaml properties, and the fallback method is the method name which it should fall back to in an event of a failure. So this annotation is the only annotation which is needed from the code perspective. The rest of the configuration will be there in the application.yaml file. This you can go into the repository and take a look how it is modeled. It's simple project structure. So we will focus on the application.yaml properties. The line number 17 to line number 28 is basically the management configuration, which is the health API or actuator configuration. This is very common. You can just go and watch my actuator video. These configurations are there. Now the main configuration for this circuit breaker implementation is the configuration which is available from line number 4 to line number 15. So what it says is, this is the configuration for Resilience4J. What we are configuring a circuit breaker. What are the instances? Instances are service A, right? So as we have defined here, there is a service A instance and a service B instance. For the sake of simplicity, I am just configuring service A instance. So in an application.yaml file, service A is the circuit breaker instance which we will be using. Now there's a property on the circuit breaker which says register health indicator. So I have made it as true. Now the other important thing in a circuit breaker is what is the window type of the circuit breaker, right? So Resilience4J offers two kind of window type. One is a count based and the other one is time based, right? So one is count based, other one will be time based, right? So if we choose a count based, so what it will do is it will basically assume a sliding window of a count, right? So suppose we have chosen a window type of count based and we have given a window size of let's say 10. So it will just keep track of the last 10 calls, right? The window size will be 10 API request call. So out of this 10 API request call, how many number of requests have failed? So that will determine the failure percentage. So the failure rate threshold, right? So this is 50. So this is basically is in percentage. If 50% of 10 API calls are failing, then the circuit breaker will turn itself into an open state, right? Similarly, in the time based, what will happen? This 10 window size will become a 10-second window size, right? So in this 10-second window size, suppose 100 requests are coming, right? And out of those 100 requests, 50 requests are failing, which means 50% of those 100 requests are failing in a 10-second time window, right? So that will again open the circuit breaker. So there are two type of window. One is count based, one is time based. So we are making use of count based for this particular example. So we just have to remember that in an count based, whatever will be the whatever is mentioned in the sliding window size, that will be the number of calls which is being monitored. So 10 number of calls will be monitored, and out of this 10, if all 10 are successful calls, then it will not go into an open state, it will be in a closed state. If out of this 10, 50% of the call, let's say 5 calls or 6 calls are failing, then that will indicate a circuit breaker to go into an open state. Okay, so sliding window we have understood, sliding window type we have understood. Failure rate threshold is how many percentage of calls are failing, right? So this should be more than or equal to 50% of calls. Then wait duration in open state, which means once a circuit breaker goes from closed to open state, how many seconds it should wait in the open state before it goes back to the half open state. So I have shown here, right, that when a circuit breaker goes from closed state to open state, it actually waits for a certain duration and then it goes from open to half open state. So that is what this property will do. So wait duration in open state means how many seconds it should wait before going into the half open state. Then the next is minimum number of calls. So minimum number of calls is basically the minimum number of API calls which needs to be executed before circuit breaker calculates the failure rate, right? So if we have a sliding window size of 10, so at least 5 calls should be present in order to calculate the failure. So if there are calls more than 5, like 6 or 7, and out of those 7, if 3 had failed, so 3 by 7 into 100, right? So those many percentage have failed. And if the minimum number of call is 5 and we have only made an API request to 4 API requests, then it will not calculate how many requests has passed and how many requests has failed. So simply this is the minimum number of calls which needs to be passed, which needs to be executed before circuit breaker calculates the failure or success threshold. Now the next configuration is automatic transition from open to half open enabled. So this by default is false. By making it true, what we are doing is we on the background some threads are running, right, which is constantly monitoring that the circuit breaker is in open state, and now it will automatically get transition to half open state. Okay, so those threads will continue working on the background in order to transition from open to half open state. So by default this is false in a circuit breaker configuration. If we just comment out this property, what it will do is it will, when it goes to open state, it will stay in the open state irrespective of the wait duration which is mentioned here, unless we have invoked one more API request. As soon as we invoke another API request, it will go to the half open state. But if we use this property as true, so you don't have to invoke any API. Once it has gone into open state, it will automatically go to half open state if this number of seconds have been passed. Okay, so this is another important property. Now the last property is permitted number of calls in half open state. So this value, this number 4 or whatever value we will mention in this property, this will calculate, this will basically check that how many number of calls needs to be permitted or allowed to invoke the service B or the end service when the circuit breaker is in half open state. Let me again refresh what are the properties. Register health indicator true, which will register all the health parameters. Then sliding window size is 10, which means a block of 10 requests will be used for failure rate calculation. Sliding window type is count based. Failure rate threshold is 50%. Wait duration in open state is 5 seconds. After 5 seconds, it will automatically get transition to half open state because of this property, which is enabled as true. Minimum number of calls which is required to calculate the failure rate is 5, and permitted number of calls in half open state is 4. Okay, now we are clear till here. Now we will run our application and see. Now the application has started. Let me go to the Postman collection and see. So if you see localhost 8082 actuator / health. So in this health endpoint, we'll just look upon what are the health metrics. So the service A is the circuit breaker which we have configured. The status is up. Now the current failure rate is -1%, which means we have not invoked any of the API, so the failure rate is -1%. Failure rate threshold which we have configured is 50%. Slow call rate is also -1% because none of the API has been invoked till now. Slow call rate threshold is 100%. So this is coming from the default configuration because we have not configured the slow call rate threshold. Now the buffered calls is 0, slow calls 0, slow failed calls 0, failed calls 0, not permitted calls is 0, and state is closed. So this means the circuit breaker is working properly fine and the status is closed. Now let me invoke the success APIs, okay, which will basically, this will basically replicate that the services are working properly fine, there is no fault in the system. So if we invoke, first time we are getting the response, second time we are getting the response, third time we are getting the response. Now if you go to the health check, as you can see the buffered calls are 3, okay, the failed calls are 0, and state is closed, and you can see still the failure rate is -1%. So the circuit breaker has not yet calculated the failure or successful based upon these 3 requests. And why is that? Because in our application what we have mentioned is minimum number of calls to calculate the failure or slow rate is 5. So we have just called thrice. So let me again call twice, 1 and 2. Now if I refresh it, you can see the buffered calls is 5, failure rate is 0%, which means out of these 5 calls, all the 5 calls are successful calls. So what we have configured as a failure, we have configured as 50%. So if the next 5 calls which I will invoke, if those are the failure call, this should update, right? So this is the failure API. I'll just invoke this error twice, thrice. So 3 times I've invoked a fail scenario. So this should ideally change to 33% or something. Let's say 37.5%, which means out of these 8 calls, 3 were failed. So 3 by 8 into 100 is 37.5%. But still the circuit breaker is in closed status because this has not yet reached the 50% threshold mark. Now to make the circuit breaker in open state, what we need to achieve is we need to achieve a failure rate of 50%. So let me again error response. Now this time it's 44.444%. Now again error response, and it is 50%. So which means circuit is open, it is in the state of open state. Buffered calls are 10, failed calls are 5. So it should ideally wait 5 seconds and it goes to half open state, right? So after 5 seconds it has gone into half open state. Now it will be in half open state until and unless the number of permitted calls which we have mentioned is being invoked, and it calculates the failure or the success, right? So suppose let me first invoke all the failures. Let's say 1, 2, 3. Now the circuit breaker is still in the half open state. Failed calls are 3, buffered calls are 3, right? And the number of permitted calls were 4. Again I will invoke once again, and as you can see this has gone back to the open state because all the 4 calls which were permitted was failing, which means the failure rate is 100%, and the circuit breaker goes back from half open to open state. So as we can see into this diagram, so after a certain duration it went to the half open state, and in half open state we invoked 4 API requests, and all of the 4 were failure, which means 4 by 4 into 100 is 100% of the API requests were failed. So it has again went back to open state. Now it is in open state. After 5 seconds, as we have configured, it should ideally go to half open state. So it has gone to half open state. And now let me just invoke the successful APIs. So this is 1, 2, 3. So now still in half open state, buffered calls are 3, failed calls are 0. Now buffered calls are 0, and this is in closed status because all the 4 requests were successful, right? So this is how the circuit breaker changes its state based upon the configuration and the API call which we are making. We had implemented this property, right? So let me just turn off the automatic transition from open to half open state, and let me just also turn off the permitted numbers of calls in half open state. Now what all configuration we are left with, we are using a count based window type. 10 is the number of calls which needs to be monitored. Then 50% is the threshold. Let us make it to something as 40%. Okay, wait duration in open state is 5 seconds. Let us make it as 10 seconds. Okay, now let me rerun the service. Now we will see like since we have turned off the automatic transition from open to half open enabled. So now even if we have configured the open state for 10 seconds, but since this property is disabled now, even after the 10 second has passed, the circuit breaker state will be still in the open state. It will not go to the half open state. So let me just show you that. This is the health API, which means the threshold is 40%. Okay, it is in closed status. Let me just first achieve the let me first invoke this success. Now 5 calls and this is 0%. All of them are success. Now let me fail. 1, 2, 3, 4, 5. As you can see, circuit breaker service A is open and does not permit further call, which means the circuit breaker has been into open state. Now if we see circuit is open, let's count 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 seconds have passed. It should ideally go to half open state, but no, it will not go to half open state because we have not enabled this property from the configuration. So in this situation, what will happen is the circuit breaker will continue to be in open state until and unless any request is made. So if we continue to make a request, let's say this, now if you see, it has gone into half open state because it at least needs one API request to go from open to half open state. Now in the half open state, it will again check whether it will be in a half open state. Okay, it will be there half open state. So now if we suppose invoke APIs which is successful, these many successful API if we invoke, then what it will do is it will go back from half open to closed state. Okay, and if in spite of successful response, if in the half open state we would have called the failure responses, it would have gone into open state, right? So this is another property which we should take care of. Okay, similarly, I mean, in spite of count based, we can also use the time based. So let me just try that. This is somewhat tricky because we cannot guarantee that in 10 seconds how many requests we have fired. So the window size, so the window type is time based, which means in the last 10 seconds it will check whether the 40% of the calls were failed or not. Okay, then let me just increase the time window to let's make it as 10 seconds only, and we will continue monitoring it. Okay, the service is up. Let me go to the health check, and it says 40%. Okay, and it does not show what is the count, what was the window size, like count or time based, but this is the time based. So in 10 seconds we have to invoke how many 40 40% of the API request to be failed, right? So let's suppose first request fail, second request fail, third request fail, and then success. One request, two requests, three requests, four requests, five requests, six requests, seven requests. As you can see, circuit is open. Okay, number of failed calls is 2, buffered calls were 4. So basically out of these 4 calls, number of failed calls were 2 and not permitted calls were 5. So the circuit breaker is in open state. It will still be in open state. Okay, sorry, it has gone to half open state because we have enabled this property. Now if we just continue invoking the failure, it will go back to open state. So it has gone back to open state. So after 5 seconds it will come back to half open state. Now if we continue to invoking success response, so in the time of 10 seconds, how many successful response? As many as we can. Then it will go to the closed state. As you can see, closed state. So this is pretty simple. I mean, it depends upon the scenario, like or the use cases which you should be implementing, the time based or the count based. Okay, so this is how the circuit breaker using Resilience4J can be configured in a Spring Boot application. So this is pretty simple. So this is one way of configuring the circuit breaker by using application.yaml file, but there might be some limitation in your application and you don't want to use application.yaml file. Then it also provides the annotation based or the code based configuration. So if you can just go to Resilience4J circuit breaker. I will link this site in the description box. If you go to circuit breaker, you can see you can read about this. So these are the properties which we configured, right? These are the default properties which is mentioned. So in Java code also you can configure the circuit breaker using this way. Right, circuit breaker config. Then you can also provide the failure rate, slow rate, wait duration, permitted number of calls, and half open state, minimum number of calls, sliding window which is time based or count based. Okay, and you can also configure this way, the way which we configured, which is by using the where is that, let me just check, by using this way. Okay, the application.yaml file configuration. Okay, so I think pretty much that's it for today's video. If you have any question or if you don't understand anything in the video, just put your comments on description box. I will try to answer that, and I'll put the link of this project as well in the description box. So let me know if you have any topic in your mind which I need to cover. I'll try to cover that. Till then, bye bye, take care.